A very useful trick in algebra is to be able to break up a fraction whose denominator can be factorized into a sum of fractions with single factors as their denominators. Let me start with the really simple example 8 over x plus 2 x minus 2. We know that when we do addition of fractions with different denominators, we find a common denominator by multiplying the two together. This means that when a denominator is a product of factors, we can split it up into a sum. We want to write this as something over x plus 2 plus something over x minus 2, and our job is to find out what these somethings are. We call them a and b. We know from fraction addition that this can be written as a times x minus 2 plus b times x plus 2 all over x plus 2, x minus 2. We have the same denominator, and so equate the numerators on each side of the equals. To deduce a and b, we can compare coefficients. The coefficient on the x is a plus b, which must be equal to 0, since there is no coefficient on the x on this side. And the constant term, minus 2a plus 2b, must be equal to 8. Solving these simultaneous equations tells us that a is minus 2 and b is 2. The exact same process of splitting the denominators into the factors with unknown constants as numerators, writing it as one fraction, comparing coefficients, and solving the resulting simultaneous equations works in most cases. One case we must watch out for is when we have a repeated root on the bottom, like for the following example. Here we must include in the separate terms denominators with and without the squared. With this complete setup, we can again write as a single fraction with the same denominator as the left-hand side, clean it up, compare the coefficients, and solve the simultaneous equations.